Good afternoon. All right, I'm ZJ and I'm the CEO at FlowFuse. I used to be a software engineer at a company called GitLab where we build software for software developers. And now I'm in a space where we build software for people that want to connect this to the cloud and the cloud back to these devices. FlowFuse is the software suite built around the open source Node-RED offering that allows IT and OT to collaborate in one low-code interface where we allow AI to help your developers to get the most out of the infrastructure that you already bought and paid for, as well as allow you to onboard new machines and movable assets to the rest of your data. At FlowFuse, we enable you to connect, collect, transform your data, but also transport that data, store your data in a database, visualize it with dashboarding environments, and then make decisions and push those decisions all the way back into your machines so you have smooth operations and can iterate every week on making your production more efficient, safer for your employees and the operators, as well as more predictable for the organization at large. I welcome to talk to you at our booth as well. Stop by and hopefully you have a great session today.
Please welcome to the stage, FlowFuse.
Thanks. I was promised it was Eye of the Tiger when I came up, so I'm sorry for the disappointing music. Either way, thanks everyone for taking your time today. I'll wait a second until the slides come back up. Security is apparently in our way currently. First of all, so FlowFuse. We have a booth downstairs, and in our booth we took the model factory that's the data we've been shared with, and there's an Enterprise B, which is a multi-site, I think like a Coca-Cola factory or something along the lines where you have sugar and a couple of juices and you put them in a keg. What we've done there is take the power of open source software like Node-RED and the rest of the FlowFuse offering to actually create a new site. So we have a new mixer and a new packer that puts the mixed juice into the keg. And with that, we had to traverse like the edge. So how do you get data from the device? How do you make, in this case, like a stack light go orange or green when you're mixing, for example? But also data transformation. So if the data is on any protocol, for example, OPC UA, but like level 2.5 and up on ISA 95, and your architecture is, for example, MQTT, how do you take that data, then transform it, and move it onto MQTT? But also the other way around, right? Like if a decision is made, however that decision is made, how do you get it back from where that decision is made into the mixer or the packer? So full suite is where we can apply it. Then in terms of manufacturing and where you folks are at, if you were to raise your hand if you had 50% of your assets on the shop floor connected, could you please raise your hand? Okay, a few less than I was expecting. And then follow up, if you were raising your hand, do you feel like you have access to all that data? And if you have a question that's holistically on multiple data sources, can you answer based on those data? If that's okay. No hands left, all right. And then we can actually skip this one because this was the final elimination question. But in terms of where we really focus our efforts as a platform and as a company is to be the bridge between IT and OT. What we see with our software is that OT is generally the first adopter of it, and then we work with IT to make sure that it is within the bounds that IT sets. And then on the flip side, like IT gets OT to collaborate on the IT infrastructure, make sure that the data is available throughout the enterprise. So now I'll hand it over to Chris, who will show and prove it like the way we operate.
Hello, everyone. I am Christopher Sandoval. I'm the developer relations advocate at FlowFuse. If you've ever taken a look at our YouTube channel, that is me. Hello. So this is our demonstration. If you walk down to our booth, this is what you're going to see on the level 4 side. We actually have 3 sort of monoliths. One of them is level 1, 2. Then we have level 3. This is level 4. So what this basically is in terms of narrative is it is an MCP implementation that allows you to connect to data and do some really interesting things with it. So let me show you the sort of flow that you would be looking at. So the first thing I want to point out is what I have open here is FlowFuse Expert. FlowFuse Expert is built in throughout our entire platform, and it's a way, if you're using the support tab, to go ahead and get support documentation, blueprints for things that you're building, things that you want to iterate. You can get advice on that is agentically generated with a RAG system, retrieval augmented generation, that gives you factual, actual, referenceable material, so you're not just in the dark. In terms of what we're showing you here, this is our MCP Insights tab. So once you have selected something, we can ask a question like, what is my worst performing site, right? You're a C-suite exec, you wake up in a cold sweat in the middle of the night, I need to know. And so you hop on, this can be on your phone, this can be on your laptop, this could be on your smart TV if you're a glutton for punishment. You can ask this question literally anywhere that you can get a tab loaded for the internet. Now, what you probably saw on the right side, we are sending every single query out as a payload that can call a defined tool. The way that we've defined this on FlowFuse is defining things as tools, as resources, or as prompts. And the way that I have always said it to anyone who asks, what does that mean? Tool is something that an AI agent can do. A resource is something that an AI agent can know. And then a prompt is something that the AI agent can ask. Okay, so by differentiating what you want to work with, you can do some interesting things. So, okay, based on the latest operational data, Site 1 is showing the lowest overall performance metrics. I would call out at this point as well, the data that we're looking at is actually 3,365 rows of data from a QuestDB database, each that has 12, 13 something columns of data. And this 1.14 second metric, that's not our time lag introduced, that's OpenAI's time lag introduced. So this is a very, very efficient system. So let's say, okay, Site 1, obviously an issue. Who is the manager for Site 1? I'd like to have someone go and check that out. What this is going to do now is it's going to look through all of the tools that the MCP has defined within its server and say, okay, using natural language processing, what are they actually asking? This can be as malformed of a query as you want. I was building some of these functions last night at midnight, or this morning at midnight, so the queries are not always as well formed as this, and it still worked. So in this case, the manager is Dennis Sandoval, located in San Francisco. Okay, well, I need to know, is that person actually at work? So is Dennis at work or on vacation? This is a typical thing. You need someone to go look at the site. I need to know if they're actually able to go look at the site. That's going to change a lot about what we do here. Every single query that I'm giving this is routing to a tool and doing combinatory routes. What I mean by that is we are referencing site manager data. We're referencing machine data to keep checking that that actually is a poor performing site. We need to look at, okay, so please check the vacation information. It's very kind sometimes. So it's going through all of these different systems. You can see it just pushed a query out to the specific tool, and it'll give us all of the insight we need in order to make the next query. The way that I have explained this, so yeah, Dennis Sandoval is currently on vacation. The way that I've explained this is this goes beyond data and goes beyond information and goes into something called meta-contextual data. It is not just the data you're getting from the machine. It's not just the data about who Dennis Sandoval is. It is where that data was generated and what state the machine was when it was generated, what the OPC UA tag was, what our ERP is telling us, what the MES is reporting. All of this can be combined together. You can do very, very complex functions. If you look in the middle of the screen here, there's a resolve chords and build open media URL. If I decide that I want him to drive down or want the next person to drive down, maybe they're in Reno and they're not anywhere near California where Site 1 is. Or maybe, they have to fly. I want to know what their weather is like. I want to know if that's a fair thing to ask of them. So this implementation, I think, is not only a really powerful implementation, and there's quite a bit more you can do with this. If you go to the booth, you can take a look. It's very, very flexible. This is one small slice, and this is like a small section of a small slice. This could be applied for everything. I'll give you a personal example. This could be applied to wiring your Keurig to go off based upon a sound that you hear from a piezo detector, right? It could be literally that small. It could be as complex as managing your entire calendar through actionable, this thing at this site needs to be scheduled. Go programmatically assign everyone to this functionality. So this is our MCP demonstration. There's a lot more there. I can keep asking questions. Or we can move on to the next section.
I will add, the first production use cases we see, especially in the tools area, are limited. In manufacturing, obviously, changing atoms back to the way they were formed before is harder. So especially the resource arena is currently most deployed. So you have the ability to, in natural language, understand what on the edge is happening on a certain machine if you know about that machine, or on a high level, ask questions. So what we're mostly seeing in our business is that we are combining IT and OT, and on both sides of the aisle, there's the other side they don't know, and this provides you a sparring partner and something to chat with, to ask a couple of questions and get just more context before you go into the conversation with the other teams around.
Yeah.
All right. Yeah, so the other thing we're seeing is, well, I used to work in IT, and we were maintaining a pretty big website. We had millions of users, and I was always impressed with how good my engineering was, because we stored gigabytes of data. Then I transitioned into manufacturing, and I learned gigabytes of data is your daily repertoire. And what I saw there, however, is gigabytes of data are very siloed in terms of storage and how they are accessible. So what you'll see is multiple databases being placed. You need to know which database is in play, where, what it stores, and what the context of the data is. So yes, there's a lot of data. And at first the mandate was, let's just store all the data, and then you saw just the number of data points you store and the amount of gigabytes into petabytes after a while. But the information getting out of there was, and still is actually, fairly limited. That's just because, first of all, like, to what extent do you actually want to store all the data from, let's say, retention over 30 days? The question is it valuable at all? Does it provide you information? And even if it does, then it's still in desperate systems. And what we also saw is, like, the interface. Everyone these days ships with dashboards, so you have now 20 dashboards, and you still need to know which dashboard to go to. Like, maybe this one is hosted in your MES, and the other one is hosted in Ignition, and actually finding this information is much more difficult than it should have been. And then on an organizational level, they're gonna try to fix this, right? And so they say, hey, we have 14 ways of doing one thing. Let's try to standardize, and we create a 15th way of doing it. There's a very famous XKCD about this, where as soon as you introduce one standard, what you're actually doing is introducing the next new competing standard. So that's also what we're seeing there. And then, okay, organization top-down, there is a solution, and so what we're gonna ask, everyone's gonna write documentation. So you're gonna dump your brain in this document. But about the same thing really happens is where you write it down and now you store it somewhere. The other person might not read it or interpret it differently than it's written. They might not find the answers that that you haven't written down when you were writing the documentation. So the answer is not really there. Then information is also IP. So some information might be hidden to some people in the organization, while they do need that information to answer their questions on their work. And so after a while, the manager's like, okay, we're gonna make this process driven. So if you need access to this, then you ask Joe or you ask Pete, and then after a while, Joe or Pete leaves. Like, there's a bunch of problems there where what you see is actually innovation slowing down because people don't have the tools, they don't have the capacity to actually get the progress they want to see. They have hunches, they have ideas, they want to fix within manufacturing and make everything better, but after a while they just stop with actually making the steps needed. They stop asking because it's just too hard to progress from there. So yeah, 2026, people will yell, just use AI. I'm not an AI Luddite. I like AI, and I spoke about it before. Like, IT doesn't know anything about OT, and it's great to have a sparring partner. OT doesn't know about IT, so someone yells snowflake, and at first someone in OT might be like, what's the snowflake doing in this context? So like, there is a bunch of use cases for AI, but it is now being used as like the true fix for everything, and we slap AI on it, and now it's all better. Which is not the case. First of all, obviously, it's not magic. It's not magically implemented. Like you saw on the flow that Christopher just showed, there is just implementation to be done. there is things to notice. So we just had to explain on MCP there's resources, there's tools and prompts. It has its own language, and like it's not just to slap a sticker on it and it's done. And so with new technology, there are new requirements. So the one thing I already spoke about, if you use tools, you want to limit like the exposure of changing the environment in manufacturing. The other thing I didn't discuss is there's a lot of information, there's a lot of IP actually stored in all the resources as well that you might expose through MCP. So you have new requirements now on like who has access to what. And actually, what I'm really doing here is repeating 2 slides back. Like there's all these problems that will remain even with AI. So yeah, IT, OT, there's still pressure there between the teams. Again, the last point as well, like we can't just slap a sticker on it and it's done.
Yeah, so the question then is, what does good look like, right? If it's not a solution of let's just slap everything on, let's call it good, it's AI, what does good actually look like? So what do we need for a practical deployment? There's a couple things here. The first one is we need in situ data and information conversion. What I mean by that is where you're generating the data is where that processing should happen. It should not go through all these crazy systems, go completely out. You can go out for the agentic part of it, but not having the meta-contextual things that are tied to that data, not having an understanding of how that data was generated, in what context, at what time, from what operator, from what site, all of that information has to be part and parcel with that data. And what that naturally sort of leads to the next stage as is context itself must be a first-class data resource. We have gotten past this point, as EJ alluded to, that there was a period of time where we were, it was hard to get big storage hard drives, right? Now we're talking about solid state NAS solutions. Like I have a solid state NAS at home. That's crazy. I could not have imagined that in 2008. And so now we're at this point where context is much more important than volume. And we haven't really reached that point yet where everyone is sort of in agreement that that is the thing we need. So in order to start solving this problem, context has to be a first-class data resource. And as part of that, you say, okay, again, getting back to, well, let's create a new standard, let's put these processes into place. OT engineers, people who are building in reality, are already overtaxed, okay? Building this demo downstairs, like stripped my fingers pushing wires into a million holes. I don't want a new thing to maintain. I want it to be simple, I want it to be universal, I want it to be easy to learn. Don't want to have to go get a college degree to figure out how to get my PLC to talk to me. Don't want that. I want it to be flexible. And the second you hear flexible, my education is in comp sci and network admin. The second I hear flexible, I think insecure. So then you get into the IT side of things. It's not good enough to just be flexible, has to be secure by design, has to be low friction. All of these things seem to be in competition with each other, but the reality is that this is a universal problem, and this is not just FlowFuse saying this is what good looks like. This is what good looks like. In a perfect situation, this is what good looks like. So FlowFuse's solution, the way that we made this work is to take the way that Node-RED, which is the basis of FlowFuse, the way that it interacts with everything, the way that it interacts with processes, and to expand that out beyond just the small piece and to expand it to actual flow functionality. So before we continue, let me show you how this is built in situ itself. So what you're looking at is a single FlowFuse instance, okay? If you're familiar with Node-RED, it's gonna be very, very familiar to you. As I said, everything is defined by tools, by resources, by prompts. I'll walk you through one tool. Here we have retrieved data from time series database. This is potentially the simplest tool in here, which is wild considering what it's doing. What we basically have is give it a name, assign it a server, give it a tool name, something that can be actually understood, can be processed, can be figured out by the MCP, but then give it an adequate description. Say what it should do. Give it a perfect view of if this executes perfectly, this is what it should look like. If you need some sort of other stricture around it, there's other things you can do. You can give annotations. So in this case, it's read-only. I don't want it writing to my time series database. That's nonsense. But it can go to the open world. It's going outside of this collection of instances. If I were doing something like the location trip planner to jump really quickly to another one, here I've actually given it a schema. It knows exactly how this should be formed. Anything that is outside of this is either going to be rejected or remixed into the schema that I've given it to process the way it should work. So getting back to our original table, we have the request coming, or sorry, the original node. So coming back into the tool, we then form this query. We send the query onwards with all of the different variables that we need to drop in. That goes into a caching solution. Now, the way that this is built out is actually going to another remote instance where the data is being generated. So you have this instance that's doing all the MCP. It sends the request out to the local instance and says, hey, you own the data, give me this data, check to make sure you can give me that data, that the permissions are right, that I'm doing the right thing, that I'm not sending a malformed query. Process that query in the node that holds the data, then send it back. While that's happening, we're caching the ID for the request so that when that data comes back, we can bring it together and say, not only is here the 3,000 lines of data you requested, not only is it here, this is the context of when it was requested, by whom, for what reason, and to what end. So now you don't just have the raw data service, you have the context of that data service. And finally, we release that back to both the local instance for any caching that needs to happen. We can send that back through, and we can send it as part of the MCP response. And that whole flow that I just showed you is essentially this in short form. It is the full array of how we manage to make this work. We are defining tools resources, sending it out. We're using device agent to send to all of the local nodes, all of the processing, validating, remixing, sending it out to process for AI, sending it out to other nodes, and then bringing it back and surfacing it. So this is another big piece of this. The implementation that we used AI for here is not just the MCP part of it. We also have what I showed you at the beginning, which was the expert that can tell me, you know, am I building this right? Do I need a better blueprint? Do I need a better solution? AI on FlowFuse helped us with every single piece of this, every single piece. When I was creating the flows, there were times where I was like, man, come on, it's 1 in the morning. I don't want to write JavaScript right now. Please give me a random number generator, right? Generates it, tells you this may be right, this may be wrong, take a look at it. I think this is right, this is the blueprint, go take a look. Maintenance, I was working with a bunch of people. Anyone who's familiar with FlowFuse, we're all across the world, okay? Being able to have my partner Drew code something and then have me jump in and do a flow explainer so I can see what he wrote without me having to wait for him to be online is a game changer, and it's AI driven. And then finally, the contextualization, which is everything that I just showed you, plus all of the meta context, is really what made this work. So, okay, prove it. Real world case studies.
Yeah, so the factory we rebuilt downstairs in our booth is actually a case study, again, that we implemented with one of our customers. So what they did is they saw a couple of sites and they were actually functioning well. They just needed one at a new location. So they copied their brownfield into a greenfield. And people really say that greenfield exists. They changed a couple of factors where they weren't happy with their current setup. But otherwise, like if you can just copy your whole organization, like one site in terms of manufacturing into a new site and then train the new personnel to be effective operators and then bring IT on site and OT on site to maintain that, you already have a lot of learnings on site. And where also like downstairs, it took us about 40 hours or so to basically take that IT, the learnings from it, and transition that into the new site. That's about the solution here as well. Now you do have new people on site, new people on staff, and you need to train them as well. The key property here is that with both low code, but also with the AI experts, the time to learn is just reduced by so much. Like the information is available and accessible for many new people. Yeah, and then over to you for the...
Yeah, so another really good example here. I'm from California, so anyone else who's from California, Nevada, Utah, any of that, we know water is like non-existent. we love it, we don't have it. So this is actually a very good example that's local to me. So Water Management Org has distributed devices everywhere. Obviously, you don't want to send someone up into the Sierra Nevada to check on one sensor, right? Well, you can use Node-RED to connect all those sensors together. Great, you're ingesting all of your data. But what does any of that actually mean? And what I mean by that is, let's say you have a sensor that's saying, hey, we have low water pressure, or the aquifer has low quality, or we're not getting as much of the snowpack melting downstream as we thought. That investigative process is so heavy and takes so many steps and takes so many people that you have to have a team of 12, 13 people, let alone the person who goes and checks the device. You now have to go through tables. You have to go through comparative analytics. You have to figure out, okay, was there a local fire? Because fire could affect the ash particulates, and that could affect the way that the rain sets into the ground. And anyone who's familiar with fluid dynamics, especially when it comes to actually infrastructural management of water, this is now a much more complicated process. And when you are a small county, especially like much of California is, if you're Los Angeles, San Diego, you have millions of dollars. If you're a little podunk farm land out in the middle of nowhere, like my area, but you still have water needs, how do you manage all of this at scale? And so the solution is AI and MCP. You connect all of your data, you collect that data, but then you use open data. You use weather reporting, fire reporting. You use NOAA satellites. You use systems that tell you air quality readings. You use snowpack readings. You use all of these systems that give you a much richer view of the potential impact on this small data set. And suddenly you understand, oh, there was a fire. That fire spit ash into the air, that ash settled, the water therefore does not seep as deep into the aquifer. 3 months later, we can expect a decline in both quality and amount. That is something that would take months and millions of dollars for a typical team to figure out. And it can be done relatively cheaply.
Yeah, and then this is a Dutch use case, so that's why I'm awfully familiar with it and excited about it. But it's fairly cost efficient to roll out, well, it has been roll out solar in the Netherlands, because what the government used to do is say like, hey, you know what, you can install solar, we take your full year productivity and you subtract your consumption minus what you produced, you only pay the leftover. Amazing deal. So what ended up happening is like it cost the government a bunch of money. So what they then do is say like, okay, the deal is off the table. And we, like myself, but also others, had to figure out like, what do I do with my solar now and how do I make it cost efficient? So one of the things that we done with another organization that's now our customer is make sure that we put little Node-RED devices on next to the meters. With Modbus, we can now understand, first of all, like, do you have a home battery at home? What's the state of charge for it? We have weather data, and so we also know what do we expect to produce. And the last thing that is also attached is electric driving is very popular in the Netherlands. So if you plug in your car, when is the cheapest time to start charging? The problem, however, is like, you can't tell people at home how Modbus works. You can't tell them like the limitations there, but they do want to interface because now they have this system and they're paying for this system. Like how do you make the most of your consumption and production and reduce your costs? So that's where we started working with them, also with MCP, and try to analyze like, hey, how do people want to interact with this? Prompt-based interaction with infrastructure is getting more common, like people are used to it, where it seems like everything is a prompt now, but that is with a reason, because it's very natural, and text is the way you learn basically since you're 4 years old how to communicate. So we're quite excited about the opportunities here also for residential solar opportunities and energy management, for making smarter decisions with humans as well. Because if I know I need my car charged at 80% state of charge because I'm leaving soon for a long holiday or a long trip, I just want to interface and say like, charge it no matter the cost. However, if I park my car now and I don't need it until tomorrow morning, get me the cheapest way of actually charging my car. So the point here is like, first of all, we have thousands of connected homes, so we know the production. We can kind of predict what the price is going to be of energy. And so as a cluster, we can now make smart decisions and collectively bid on energy. So that's a more residential use case. In terms of energy efficiency, there's a bunch of other use cases where
for Enterprise B?
Yes.
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 Okay, we're running really close to time.
Oh, okay, cool.
Perfect.
Talk to me later about solar. I love that stuff.
So everything that we were showing you for MCP, this is actually based entirely on Enterprise B. So what we ended up doing with Enterprise B is we pulled in our ProveIt site for MQTT, and we ran everything through remixing. We completely remixed the data. We, in addition to that, built our Site 4. And in order to make all of this surface to the actual MCP, we had to consider all of the things that we've been talking about. Who's going to maintain it? What does it need to look like? What systems is it going to connect with? How many people is it going to take to actually make this work? So the first step that we went through is going through our topic normalization. We had to normalize the entirety of Enterprise B. We had to write it to exactly what we wanted it to be, which anyone who's ever worked with brownfield, greenfield split, you're very familiar with this process. You come into something that someone else has developed. I've made this joke to pretty much everyone here. The best engineer is me, and therefore I'm going to make the best greenfield, right? And so you set your standard of what you want. You go through your topic and asset capture, you rewrite that using the global store, and now all of a sudden, all of this disparate data can be surfaced up to the MCP in a way that is recognizable, that is determinative, that can actually be referenced. Now, what comes out of this is a couple things. The first thing that we do is we write all of this data, as I said, to QuestDB. QuestDB is our time series database. We are also republishing all of this data to our own internal MQTT. So on FlowFuse, there is an internal MQTT. Actually, I'll come over here. We run our own broker. We've ingested everything. We are republishing in our own format, our own structure, in addition to publishing in a form that our MES can see, that our ERP can work with, that OPC UA can actually recognize. From that, we have all of our instances split out by machine center. So we have our packer and mixer, which is our Site B. Our Site 4 as part of Enterprise B. Those are managed as remote sites. Those are actually Groove Rios. They each have their own flow that is basically detecting any state change, and those state changes are exactly what you would think. We're using Groove Read and IO, and we're just pushing that back through both OPC UA and MQTT for the variable tagging, and that is driving the entirety of our stack lighting, of our mixing process, our fluid simulation. As an aside, anyone who's into fluid simulation, come see the booth. I'll tell you the physics simulation I did on that. It's kind of crazy. All of this is being driven through a mixture of remote instances, of cloud instances. I think at total we have a couple hundred nodes, and I believe we have 10 instances. And that is the rebuilding, the restructuring. They're probably playing with the buttons right now. But everything is coming in through Enterprise B restructured so that this works. All of that work has to be done to make sure that this is actually useful, is contextual, and is valuable. So yeah, that's our demo.
Awesome. No, I appreciate it. Thank you, guys. So, talking about the questions that we're answering. So you guys leveraging FlowFuse.
Yes.
Pulled in the information from the MQTT Enterprise B. You added an additional fourth site that we see down here at the booth, but we just took the slide away. And then it was the executive chatbot solution that we were talking about of what does my site look like? Okay, perfect.
Yeah.
And then, here we've got the slide up. Thank you guys. I don't know who put it up, but thank you guys for putting it up. And so you guys, 48 hours?
Yeah, so in terms of our entire scope with the Site 4 build, that includes all of the data simulation, the fluid dynamic, everything, the Site 1 through 3 integration, which is both the remixing, the ingestion, the full stack architecture of Odoo, of Ignition, PLC, MES, ERP, all of the agentic, everything, all of that plus the dashboarding comes about 48 hours.
Okay.
All told.
Perfect. And then licensing cost. That is always the big one.
Yep. So FlowFuse Enterprise is available at $20,000, and that surfaces all of the AI functionality, the MCP, everything that goes into that. But it also surfaces granular role-based access control and device management at the edge, on-prem, and cloud, a whole host of other things.
Okay, and then the AI that was going out, was that going to OpenAI? Was that going to Cloud?
So right now, the way that we do it is we feed it, we basically dog food. We're feeding into a FlowFuse instance that does all of the rights verification and then kicks it out to OpenAI. the next iteration of this, we already have internal support for ONNX models. If anyone's familiar with that, that's an open standard. That is something that you can build into this, and the sort of next reach goal is to have model selection and custom model generation as well.
Okay, awesome. No, I appreciate it. Guys, you guys have probably been in these, so please feel free to go scan the QR code, ask some questions. I do have a couple of questions. So we've got a bunch of life sciences folks. Maybe, I don't know, I didn't ask the question of how many were life sciences folks here or not. But so we talked about Enterprise B, life sciences, other industries. I know ZJ talked a bit about solar, and we could probably nerd out about that for the rest of the conference, ZJ. But life sciences, other industries, where does FlowFuse, where do they fit in?
Yeah, so the reality with FlowFuse is that we don't actually care about the form of data. We care that the data is data. As long as it is a message, you can work with that message, you can remix it, you can transform it, you can make it work with any of these things. So it is less for us, it is life science data, it is readings, valuations, pressure differentials, anything that you could possibly imagine. If it generates a signal, we like it, and we can make use of it.
Okay.
The thing I will say for pharma is, but also for military and other use cases, there might be some compliance requirements. We here use FlowFuse Cloud, but exactly the same software you can run on your site. For example, if you need data residency, pharma has to deal with GXP, GMP in particular. And for those customers, generally they take exactly the same software as we run in the cloud, but then put it on site. That makes a lot of the compliance questions that you have to answer to adopt new software go away. Yeah, we've gone through GXP before, so yeah, we're happy to take someone else through that as well.
Okay, and then before we get to everyone else's questions, I get at least one more. The development and rollout. So you guys on the FlowFuse side, you are the platform. Are you doing the development for end user customers? Is that mostly like citizen development? Is the go-to-market through integrators and other solutions providers? What does that typically look like?
A bit of all. So we are not an SI. We do provide some services, but most of those services is making other people successful. And generally that might be like doing together one project, making sure you understand how all the pieces fit together, but also get the ROI and actually get the first successful project. As soon as we get the first project rolling, then people have confidence and can go from there in terms of the new project, the next ROI-friendly conversion of data or next integration to build.
Okay. No, I like it. So a couple of questions. Well, I only see 4, so however many questions from you guys. Does FlowFuse integrate with Active Directory, and can single sign-on be integrated with it?
Yes. It's a SAML 2.0 provider, so if you have Azure or actually almost all are now SAML 2.0. So the answer is probably yes. No, not probably. The answer is yes, unless you do custom authentication, but then talk to us. I am going to bet 99% certain that you have a SAML 2.0 provider. Okay. So I should have just said yes.
You did start with yes,
yeah, fair,
and then you continued. So we appreciate that.
And I'll also note, since this is sort of also a security question for people who are in the IT space, when you're talking about actually being able to control a lot of what's happening here, we do have granular role-based access control at the team level, the application level, and the instance level. So you can control not only what each person is able to do, but their particular view and implementation and integration with those instances.
Okay, no, perfect. Licensing cost question, what does the structure look like? Is it per enterprise, site, geographic location, or is the, what was it, $20,000, is that enterprise-wide all you can eat?
For manufacturing, it's mostly site-based, okay, because they don't want to care about how many they roll out of something. It's just one geographical area. If you're an IoT use case like the solar, you have thousands, then it's more item-based. Okay. So it depends a bit on the situation. For most of this room, it's per site licensing.
Okay, and I'm going to ask a question I don't know the answer to. Is pricing on the FlowFuse website, or is that something that we have got to chat with you guys about?
A bit of both.
Okay.
Yeah, but it starts at 20K, and the larger customers, then we're talking 100 sites. They're not going to pay 20K a site. Sadly, I'd love that. But no, it goes down after a while. And if there's an enterprise license deal to be made, let's talk.
Okay, I like that. Question, how are you connecting the MCP to local services?
Yeah, so it is, let me jump out of this. Someone asked, why don't you build a Flow Live? So I'm building a Flow Live. We do a couple things. So we have Device Agent. Device Agent basically manages all of the FlowFuse instances that are either remote, are hosted, or any variety of singular local services. And this is all managed through the cloud, but is also managed on the server side of things. It is Docker instances, containers. And so all of our local services, all of our external services, anything can come together depending on where you want it to come together. You can bring everything to the edge and process things locally, so bringing from outside in. You can bring everything from inside out. You can do it in the middle layer at level 3. You basically, like I said, we don't necessarily care about the kind of data or the locality of that data. We care that you have control over that data and how it's processed. So depending on local services, we have GrooveRio stuff plugged in. We're using GrooveRio nodes for that. We have Postgres nodes running. We have FlowFuse tables, which is providing some static data. It is kind of whatever you need is possible.
Okay. Question here. Do you currently have a Ming solution, and can FlowFuse plug directly into the Node-RED of the Ming, and what does that look like?
No. So Ming, MQTT, Influx, then the N is for Node-RED and the G for Grafana. In terms of visualization, we do have Node-RED dashboards. That is a Node-RED community project, which we sponsor, so we don't ship with the Grafana. MQTT we do ship with, so the MI are there. For the Influx, we like the time series databases. So for the demo, we used QuestDB, and we're looking to onboard the time series database on the platform proper, but it won't be InfluxDB. Yeah, so the problem with InfluxDB really is that they seem to change their query language every 2 or 3 years. And what we're really trying to achieve with our platform is to make sure that everyone can contribute on integrating IT and OT. Changing your query language every 2-3 years is not something I'm a fan of. So that's why we shied away from InfluxDB.
Okay. We do got a bit more time for questions. If anyone else has any questions, we do have I assume it's a comment about you need to brag more about how easy it is to use, but I suppose Christopher is here putting together some flows.
In my defense and in our company's defense, we are quite European, and so we're still learning marketing, and we're still learning on how to communicate with a lot of confidence. So we'll take it to heart though, and that's also why we brought Christopher in the company.
Absolutely, and I think the last question we have at the moment is there a dark mode?
Is there a what?
Dark mode.
Yeah.
Are we too European,
So Node-RED 5.0 is around the corner. It has a dark mode. I think it's 2 months out. And also the left-hand sidebar is more configurable, is gonna float. Like all in all, like the UI is gonna be much better. So answer no, not yet, but give us 3 months and then Node-RED proper, like the open source, non-paid version will have dark mode certainly, and FlowFuse itself has already a carefully designed color that we don't do dark mode. I don't know anything about design, but I was told that it was dark mode and light mode in the same thing.
You can do quite a bit of injection of dark mode stuff with the template node. So we, on the dashboard side of things, if you want a dark mode dashboard, but you want this to look the way that you want it to, you can inject custom CSS classes both into the dashboard nodes, what they're actually creating the widgets. On this side of things, you always have the option of changing this locally. I know on my home, I don't always use a laptop. I do have custom skinning for it because of color issues. Yep. So.
Okay. Christopher, probably for you, you were talking about building the flows.
Yeah.
Does the AI not build the flows for you? Or maybe what does that look like?
It can. So there's a couple things here. The big thing is, you have to start over sometimes. For support, you can ask it a question like, how do I ingest data from an S7? And From there, it'll pull all the documentation that we have, all of the information, and it'll pull blueprints that you can just import. And so you can see here, there's guides for that, so I'll open one up. I'll walk you through step by step. If you don't want to do that, we do have a blueprint library, so you can just download, say you want instance load testing. You can deploy this directly from that page, and it'll give you an immediate way to spin that up. So you can have the AI build it, but the big thing here is you kind of have to understand what you want to build. In terms of the generation of the nodes, that's kind of not great. What you really want to do is if you're building code within the function, and some of you probably saw me doing this earlier, you can take something and say, I don't know, create a random number generator between 1 and 2000, terribly spelled, and that will actually generate the code for you on the fly. This is not a particularly complex piece of code. I can tell you the fluid dynamics was greatly helped by this because although I am very nerdy, I don't have a PhD in fluid dynamics. So, and it was able to consistently generate actual physical modeling. So it is quite capable.
No, perfect.
I have seen internal demos of like building whole blocks, not the whole flow, but like adding blocks to it based on text prompts. So that is definitely something, again, in a couple of weeks will be there. We ship new AI features every week. And also like utilization of the feature set is growing more than exponentially. So yeah, that's definitely around the corner because that is the way people interface these days and want to build. We will always make sure that the deploy button right on the top that has actual consequences is human pressed and is not something that AI can do. So before anything happens, before either control or resources are queried, there was a human that felt that it was a great idea.
Okay, I like that. So there's another question in here that someone had asked, the difference between FlowFuse and Node-RED and what FlowFuse has added onto Node-RED beyond just the industrial repackaging.
Yeah, so if you buy a car, you know usually what kind of engine you have, and it might be a V6. Node-RED is definitely a V8. It's a nice one. We've tuned it a bit, not heavily, because we still depend on the open source, but you're buying a car, so you're buying the chassis and everything. So another question is about custom nodes that are private. We have a registry for those. If you want to deploy to hundreds or thousands of devices for an IoT use case, we have all the tooling for those as well. The whole team management, SSO integration. Yeah, really you're buying a platform that yeah, you can hook your trailer to, but also take your bikes or your kids to the amusement park, so to speak, and stay in the automotive analogy. And Node-RED is an amazing engine, but it's just part of FlowFuse.
Yeah. Awesome. No, I appreciate it, guys. We are up on time here. Thank you, everyone, for joining us. Christopher, ZJ, thank you for showing off FlowFuse.
Awesome. Thank you.
Thank you, guys.
Thanks, everyone.